again. Now we will continue with Team 8. They will present a global bicycle. John, Jimena, and Roxana.
Good afternoon, ladies and gentlemen. I'd like to introduce the global design team. My name is John Bultran.
I'm Jimena Pruge.
And I'm Roxana Riani.
Our faculty advisor is Dr. Benjamin Basil. We'd like to thank our funder, Mr. Duriel Taylor, the founder of the Glowing My Mobile company. So a couple months ago, Mr. Duriel Taylor came up to us with the idea of creating and improving on cyclist safety, especially at nighttime, by increasing visibility. After several conversations with him, we came up with specific design criteria that we'd like to have for creating a bicycle that glows. The bicycle needs to be lightweight and cost-effective so that it can be marketed to the general public. The illumination of the bicycle frame, which is our main objective, has to be self-generated, and it must be safe and suitable for a wide range of weather conditions because of the electrical components involved.
This is an interactive map of the cyclist fatalities in Great Britain since 1985, as of yesterday that we updated it. And it's over the course of 30 years, so it might not seem like a lot, but the stats are still pretty overwhelming. Every week, 49 cyclists die in the European Union and 13 die in the US. 57% of these collisions, whether it's fatalities or actually reported injuries, are due to the fact that the driver did not see the cyclist. When it came to designing the illumination of the bicycle, we were looking at first what was already available on the market. And one thing that was common among all of them is that they were all externally applied components. So whether it was wiring around the wheels or and the spokes, it was just very unappealing in the daytime. It was almost an occasion bicycle. So the two things that we considered was basically LEDs or electroluminescent components. We ruled out LEDs because it just wasn't suitable for our application if we wanted to have a seamless design. And we wanted to actually have the frame itself light up, not just have small components light up. We liked EL components because it's cool to the touch, it's lightweight, it's a Lambertian reflectance, so no matter what angle you look at it, it's uniformly bright. It'll continue to function even though it's punctured. It has a low power consumption, and there's no catastrophic failure. It just decreases in brightness over time.
So energy generation is an integral component of our prototype design. And in order to have a self-generating energy system, we're going to integrate in our prototype hub generators. So this is a sample of a Shimano hub generator. And you see, as I rotate it, it powers these lights. So it captures the mechanical energy generated by the wheel rotation and converts it to an AC current, and an electrical current. That specific model, Shimano, is relatively heavy. So we're going to use, we believe it's better, more lightweight model called the Sun Deluxe Dyno Hub. This is the actual hub and generator we're going to be using on our prototype. And this is the generator laced within the spokes. And you can see it's about 2/3 of the weight of the Shimano hub. We're going to perform some initial power output testing to ensure that the power output meets the power required by the electroluminescent frame, which the paint requires about 0.7 milliamps per square inch of surface area.
The novelty of our design is integrating that hub with the EL paint and the auxiliary components for the design, making it self-sustaining, which is also the most challenging part of our project.
For our prototype, we're actually going to be using a 21-speed aluminum frame because it's lightweight, and we're going to be coating it with EL paint, actually. So if you could. This is developed by Darkside Scientific, and it's called Lumilor. So as you can tell, it's just directly applied on, and the electric current is applied to it through here. And you can program it to have different settings, such as flashing. So this flashing component we're actually going to integrate to program using turning signals and brake lights on the seat stays in the rear of the bike. We're also going to, you can turn on the lights, thank you. We're also going to integrate on and off switches for the lights directly into the handlebars to stay with the seamless design of the frame.
This diagram also shows the location of the hub generators on the front bicycle wheel.
If we can't get enough power from the front wheel hub, we are going to try to integrate a rear wheel hub, reduce the brightness of the EL paint, or our last resort would be to use an external power source. Also, we can use external LEDs and external EL components for the turn signals and the brake lights within the bicycle. This is our timeline. We'd like to have our electrical system done by January. as well as our prototype finished by March. The estimated cost for the bicycle is just about $4,000. Here are some references that we are using, and local collaborations are Darkside Scientific and Emerge Miami.
Any questions? Yes, Carla.
So is the paint available on the market?
Yes. Well, no. So Darkside Scientific, I think they patented it very recently, within the past couple years or so. So they're very tight on their patent right now, and you can contact them, which is what we did. And so there's certain products but it goes directly through them. So
You will send the bike to them and they...
yeah,
Yes.
because the application process requires a lot of layers, and there's a process to it. So you can't just buy it off the market and paint it yourself. They do train labs called Luminor labs throughout the country so that they can apply that paint. So they're based out of Medina, Ohio. So instead of me having to ship something over to Medina, Ohio, if I can actually go in person to a lab nearby that applies the paint, I can do that as well. But they get the paint directly from Darkside Scientific.
And we still have to sign like an NDA agreement and work out the proprietary issues with them. So it's available for someone like us, but not necessarily on the market for a consumer to just buy easily.
So have you, at what stage in your process will you consider the feasibility of this for a mass market?
That's a good question.
It's definitely possible for a mass market. He basically told us when we talked to him that it depends on how many bikes. So if we wanted to start out with
By him, you mean the funder?
No. When I spoke to Daryl from Darkside Scientific, he's the lawyer for them, and if it's a couple hundred initially, then they still do it by hand. If we wanted to do something more mass market, then he'd have to invest in machinery to do it, but machinery can do this application as well. So it really depends on our funder, what he wants, but both options are available.
We would also, in the future need to perform some marketing analysis to ascertain the, demand, and that's really gonna drive the mass producibility of it.
Because of the price, yeah. It's about $10 to $15 per square inch.
Which translates into?
That's what we're also going to take into consideration for our scope next semester, to see if it's important to illuminate the whole frame, or maybe just certain aspects of the frame, like maybe just the drop bars or just the fork, or something that as long as you see it, you can know it's a bike. But a really rough estimate of the surface area of the frame, at least the basic triangles, would be about 300 square inches. So we're looking for a prototype around $1,000. So if they were to sell it, like for the initial stages, it'd be probably, with all our other components, about $2,500. Because it's such a new technology. Maybe as the years go by, electroluminescent paint will decrease in price, but again, this is very recent. Again, it's not available on the market, so it's initially starting.
Thank you.
Okay, the questions I want to throw out at you. You're telling me that if you do not have enough power in this generator, you'll add another. I would expect you to do the analytical work and tell me how much power I would need in order to empower the system that you're proposing, and then compensate on the amount of paint based on what you've got in the way of capability in your design. I need to see that the three of you have done some engineering work, that your design you've predicted your input, the result, you create the prototype, and then you test the prototype to demonstrate did it meet your technical design criteria. Okay.
Was that a question or a suggestion?
That's a suggestion.
Oh, okay. I was gonna, yeah.
Because at the end of the day, you're going to send out the frame to get painted.
Mm-hmm.
You purchase the wheel. You're putting a bike together.
Mm-hmm.
I want to see some engineering work done.
Yeah, I mean, our engineering work was really the whole system integration. It's something that hasn't been put together. So again, the most challenging aspect of it is figuring out if it's going to work. We don't know if it's going to work. Usually those hub generators are intended for LEDs.
Well, theoretically predict if it's going to work, demonstrate that it does work,
yes,
and then show the difference.
yes.
Thank you very much for your suggestion. Any other questions?